Iron-carbon diagram. For detail please visit my YouTube channel and please subscribe. Iron-carbon phase diagram describes the iron-carbon system of alloys containing up to 6.67% of carbon, discloses the phases, compositions and their transformations occurring with the alloys during their cooling or heating. Carbon content 6.67% corresponds to the fixed composition of the iron carbide Fe. The following phases are involved in the transformation, occurring with iron-carbon alloys. L. Liquid solution of carbon in iron. Delta ferrite, solid solution of carbon in iron. Maximum concentration of carbon in delta ferrite is 0.09% at 2719 degrees Fahrenheit, 1493 degrees Celsius, temperature of the peritectic transformation. The crystal structure of delta ferrite is BCC, cubic body center-raised. Austenite, interstitial solid solution of carbon in gamma iron. Austenite has FCC, cubic face-centered, crystal structure, permitting high solubility of carbon, up to 2.06% at 2097 degrees Fahrenheit, 1147 degrees Celsius. Austenite does not exist below 1333 degrees Fahrenheit, 723 degrees Celsius, and maximum carbon concentration at this temperature is 0.83%. Alpha ferrite, solid solution of carbon in alpha iron. Alpha ferrite has BCC crystal structure and low solubility of carbon, up to 0.025% at 1333 degrees Fahrenheit, 723 degrees Celsius. Alpha ferrite exists at room temperature. Cementite, iron carbide, intermetallic compound, having fixed composition Fe. Cementite is a hard and brittle substance, influencing on the properties of steels and cast irons. The following phase transformations occur with iron-carbon alloys. Critical temperatures. Upper critical temperature, point A3, is the temperature below which ferrite starts to form as a result of ejection from austenite in the hypoeutectoid alloys. Upper critical temperature, point ACM, is the temperature below which cementite starts to form as a result of ejection from austenite in the hypereutectoid alloys. Lower critical temperature, point A1, is the temperature of the austenite to pearlite eutectoid transformation. Below this temperature austenite does not exist. Magnetic transformation temperature A2 is the temperature below which alpha ferrite is ferromagnetic. Phase compositions of the iron-carbon alloys at room temperature. Hypoeutectoid steels. Carbon content from 0 to 0.83%, consist of primary, proeutectoid, ferrite, according to the curve A3, and pearlite. Eutectoid steel. Carbon content 0.83%, entirely consists of pearlite. Hypereutectoid steels. Carbon content from 0.83 to 2.06%, consist of primary, pro-Fe-tectoid cementite, according to the curve ACM, and perlite. Cast irons. Carbon content from 2.06% to 4.3%, consist of pro-Fe-tectoid cementite C2 ejected from austenite according to the curve ACM, perlite and transformed ldeberite.